Hello, welcome again to another exciting time with Smafeng, and today we are going to be solving this particular question. Now, looking at my previous video, I decided to bring this question up. This question was picked from the SOA Exam FM. So we are going to see how to apply nominal interest rate as well as the annual effective interest rate in solving this question. So the question says, an investor deposits 100 into a bank account at time zero at the beginning. So the bank credits interest at an annual nominal interest rate. Now that's very important for you to note this. Annual nominal interest rate of I. You can see. So they are calling I the nominal interest rate, the annual nominal interest rate, compounded semi-annually. So the question says the total amount of interest credited in the 12th year is twice. You can see the word twice the amount of interest credited in the 5th year. So we're to calculate I. What is I? The nominal interest, the annual nominal interest rate. Now, when you look at it from my previous video, I actually talked about this. I said 1 plus I is equal to 1 plus I raised to power m. That's just not power per se, but this is just to denote the nominal interest rate compounded m period over m all raised to power m. Now, when you see this, we call this the annual nominal interest rate, while this is called the annual effective interest rate. But this question did something quite different. That's why you have to be very meticulous. And when you're reading the question, you have to be very careful. Now, it says annual nominal interest rate of I. Now, maybe when you are very conversant with this, let's say you are conversant with this formula, so that you won't miss that. In this formula, I is the annual effective interest rate, while this is the nominal, that's the annual nominal interest rate. So what I'm going to do, not to confuse myself when I'm solving this particular question, I'm going to change this to this. But I don't need to forget that I am actually looking for the annual nominal interest rate. So I'm going to say my I is going to be equal to I with this, so that it's going to be the nominal interest rate. Why I'm going to use the annual effective rate. So that's okay. Now we say an investor deposits 100. So that's 100 into. Now, what are we going to do here? We see that the total amount of interest. Now, it says the total amount of interest credited in the 12th year. The total amount of interest credited, all the interest that will be credited during the 12th year, or in the 12th year rather, is twice the amount of interest credited in the 5th year. So now how can I get this done? It would be advisable to know what is the principal in the 12th year. Now, the principal in the 12th year is the amount at the end of the 11th year. Now, because this is compound interest, at the end of the, like let's say we are calculating it. So at the end of the first year, the amount at the end of the first year becomes the principal, that's the new principal in the second year. The amount at the end of the second year becomes the principal in the third year. The amount in the third year becomes the principal in the fourth year, and so on. So the amount in the 11th year becomes the principal in the 12th year. So we need that to be able to calculate the amount of interest that is credited there. So to do that, now I'm going to say I'm going to say at the end of the 11th year, amount becomes 100. Now you can see this is a very unique formula we have. And usually, if I'm going to use the annual effective interest rate, I'm going to say 1 plus I raised to power 11. Now that's because I'm looking at the end of the 11th year. So I'm supposed to have raised to power 11. Now when I introduce 11th year, this will also, 11 will also be introduced this way. That's times 11. So I'm going to have it this way. So I'm going to say, in this case, I'm going to make use of this, and that will be 1 plus. Remember, my IM, which is my nominal interest rate, right? So I'm going to say maintain that I with the M over rather 2 here. Remember, it is semi-annually. So 2 divided by 2 raised to power 2 times 11. So this is the amount at the end of the 11th year, which becomes 100 into 1 plus I 2, this is for 2, raised to power 22. So at the end of the 11th year, this is exactly what we are going to have. But then, what will be the interest credited in the 12th year? So that simply means I'm going to multiply that with the interest, which is going to be the annual effective interest rate. So I'm going to say interest at the 12th year. So I'm going to have, that is 100 into 1 plus I, 2, over 2, 22 times I, right? So when I multiply it with the annual effective interest rate, I multiply the amount at the end of the 11th year, it will tell me the interest that was credited in the 12th year. So this being done, I'm going to focus on the next aspect, which says that that's the amount of interest credited in the 12th year is twice the amount of interest credited in the 5th year. Don't forget the word twice. So I have to find that. So at the end of the 5th year, which is going to be the 4th year, in this case, the amount at the end of the 4th year becomes the principal for the 5th year. So at the end of the 4th year, I'm going to have amount is going to be 100. No, yeah, I'm going to have 100 into 1 plus I with a 2 here over 2. Now, all rest. Remember, we have 2 there, usually semi-annually 2, but then we are looking at it up to the 4th year, and that will be times 4. So this gives me 100 into 1 plus I with the 2 here over 2, and then this will give me 8. Now, what will be the interest credited in the 5th year? This is the amount at the end of the 4th year, which becomes the principal for the for the 5th year. So what will be the interest in the 5th year, credited in the 5th year? So the interest credited in the 5th year becomes 100 into 1 plus, I'm going to have I with a 2 here over 2 raised to power 8 times I. Now this I here is the annual effective interest rate. I'm just trying to simplify, and that's why I'm making use of the I. Now remember that they said the interest credited in the 12th year is twice the interest credited in the 5th year. So that's to say the interest in the 12th year is equal to 2 times the interest in the credited in the 5th year. Remember, we have the interest rate, that's the interest credited in the 12th year is equal to 2 times the interest credited in the 5th year. So that simply means that this will be equal to 2 times of this. So I'm going to have 100 into 1 plus I raised to power 2 over 2 all raised to power 22 dot I, and then that will be equal to 2 times twice, and this will be 100 into 1 plus I. Well, this is not raised to power actually, so I have to bear that in mind. That's I2, and then this is 8 dot I. Now you're going to see that this goes with this, and then this 100 goes with this. So I'm left with this 2. So I'm going to say 2 is equal to 1 plus I2 over 2, that's about 22, all over 1 plus I2 over 2 raised to power 8. So here, just using indices, since I'm having the same base, so the powers will subtract. So I have 2 equal to 1 plus I 2 over 2 or raised to power 22 minus 8. So I have 2 to be equal to 1 plus I 2 over 2 raised to power 22 minus 8. That gives me 14. Now, remember, the question says we have to calculate the nominal interest rate, which here we refer to this as the nominal interest rate. In the question, it was I that was used as the nominal interest rate, but not to confuse what we're doing. That's why we have the sum. This becomes 1 plus I2 over 2. This will give me the 14th root of 2. That's exactly what I'm going to have, the 14th root of 2. But to calculate this, this becomes, I'm going to have, let's say, that will be 2 into the 14th root of 2 minus 1. That's exactly what it's going to be. Now, when I resolve this to find this, I'm going to have my I2 to be equal to this. So using my calculator quickly, I have 2 raised to the power of 14. That is, sorry, raised to the power of 1 over 14. You know, it can be written like this. 2 raised to the power 1 over 14 minus 1 based on indices again. So that's exactly what I have, minus 1 and then times 2. So having done that, I'm going to have 0.1015. And this is exactly what I'm going to have. So going back to the question, remember we said the I in the question, we call that I2, which is going to be 0.1015. Now this can also be written as 10.15%. So that's it. So this is the answer. Now I took it slowly, but then, you know, in the exam you have to be super fast and also extra careful. So I believe you understand what I'm doing. Thank you very much. So don't forget to subscribe to my YouTube channel. I'm going to be dropping lots of videos again and solving more questions from the Exam FM SOA. That's SOA question, Exam FM, in this topic. Thank you very much.